Welcome, and today we are going to discuss tactile switches, what they are, how they work, and how to choose the right one. We'll even do a few simple demos so you can hear the click and see them in action. So you've almost certainly seen a tactile switch in action, whether you knew it or not. A tactile switch is a momentary action switch, meaning it only changes state while you're pressing it. When you press it, the circuit closes. When you release it, it opens. There are also normally closed versions that open when pressed. But what makes tactile switches unique is the physical sensation and the audible click you hear when you actuate them. That feedback helps users know exactly when a button press is registered. They're small, reliable, and incredibly common in consumer electronics, appliances, industrial equipment, and more. Inside a typical tactile switch, you'll find a few key components: the base, the metal contact dome, the plunger, and the cover. When you press the plunger, it forces the metal dome to snap inward, bridging the two contacts. That snap is what creates the click, both the sound and the feel. When you release the pressure, the dome springs back, opening the circuit again. The material of the plunger and the exact shape of the dome play a big role in how the switch feels. Another important factor is the sound profile of the switch, as not all tactile switches sound the same. Some have a sharper, high-pitched click, while others have a more muted, thuddy feel. In products, that sound can make a device feel more premium or rugged to the user, so that's something worth paying attention to. There's also the rebound and overtravel. After the dome snaps back, it doesn't instantly return to its rest position. It rebounds slightly. Most of the time you won't notice it, but in high-speed input applications like gaming devices or fast response control panels, rebound behavior can affect how cleanly each press registers. Overtravel is how far the actuator continues to move after the electrical contact has already been made. Some designers prefer very short overtravel to create a crisp feel, while others want a longer cushion because it feels softer and more forgiving. These small, mechanical details are what people are usually referring to when they talk about switch feel. Tolerance of the operating force also matters. Two switches may both be labeled at the same operating force, but one may have tighter tolerance, meaning a more consistent feel across multiple units. This is important across devices, but it is even more important to have the tactile switches consistent within a single device. Imagine using a game controller and the buttons on the controller each have a different feel and sound. That is definitely not ideal. Finally, consider the footprint and mechanical stability of the switch on the PCB. Some tactile switches include additional posts or reinforced housings to help keep them stable during assembly or repeated use. If your device will see side loads or presses at an angle, which can be quite common, a stronger housing helps prevent premature wear or stress on the solder joints. That's one reason why SameSky offers several different housing and mounting styles, so you can match the mechanical requirements of your enclosure without compromising switch performance. When you're selecting a tactile switch, there are several specifications you need to pay attention to. The first is operating force, how much pressure it takes to actuate the switch. As I mentioned earlier, this can range from very light to quite firm depending on the application, but needs to be consistent. Here at SameSky, we offer a wide range of options measured in gram force, giving you the ability to choose whatever works best for you. Travel and actuator height also affect both user ergonomics and how much room you have inside your device. Actuator height can vary greatly, from sub 1 mm to over 15 mm and beyond, giving excellent flexibility for designers. You'll also want to think about lifecycle ratings because some applications require switches that can withstand hundreds of thousands of presses. Environmental ratings like moisture or dust resistance may matter depending on where the product is used. Finally, make sure that the mounting style fits your PCB layout and manufacturing process. So let's see one of these things in action. I have an illuminated tactile switch connected to a SameSky relay, which if you want to learn more about relays, I highly recommend you check out that video once we're done here. Right now, the LED in the tactile switch is powered through the relay's normally closed contact. When I press the button, the relay changes state and the light turns off. However, in the typical configuration, the light stays on even when the tactile switch is actuated. With this particular switch, there are 6 pins, 2 for the anode and cathode of the LED, and then 2 more each for each side of this normally open switch. With non-illuminated tactile switches, you usually just have the 4 pins. In this case, when I actuate the switch, it closes, providing power through the coil of the relay. The relay then opens the connection to the LED in the switch, turning it off. Illuminated tactile switches are great for low light environments or front panels, basically anywhere you want clear visual feedback alongside the tactile feel and sound. And again, while I have it set up to turn off the light when I actuate it, these illuminated switches normally stay lit at all times. Because of the wires connecting the switch and the relay, it's not easy to get this switch close to the microphone. And so I have a few other tactile switches that I want to compare so you can hear the different sounds they make. This switch has a sharp click when it actuates, and the feel is very similar, providing unmistakable feedback that it is actuated. This switch also has a clear clicking sound and sensation, but it's a bit softer if you want more subtlety. In these examples, you can also see there's a clear difference in plunger height, giving significant flexibility in how these will physically fit into your project. With that, we have a few quick design tips when working with tactile switches. First, always test the feel before committing to a design. Different operating forces and dome structures can make a surprising difference. You'll also want to think about how much travel you want the user to experience. As with almost every electrical switch, tactile switches will also need either a hardware or software debounce to reduce unwanted transitional signals or chatter. Finally, and perhaps it goes without saying, but make sure that the current voltage and environmental ratings are appropriate for your application. So while tactile switches may be small, they have a big impact on user experience. They provide precise momentary control, clear tactile and audible feedback, and come in a wide range of forces, heights, and features, even illuminated options, all available from Same Sky. Choosing the right one can make your product feel more intuitive, responsive, and reliable. If you have any more questions or want to learn more about tactile switches, check out our switches blogs at sameskydevices.com.